Welcome to lecture number 24. See, in last lecture, we discussed a multibyte addition using assembly language. Right? Okay, so again, we discuss the two programs. In first program, we were dealing with the hex numbers. In second program, we were dealing with the BCD numbers. In that, we modified the program with DA instruction. And you can check the result of this code. This is an assignment to you. You can check on calculator. The sum should come as 213, and that out of that 1313 will be stored in accumulator and 2 will be stored in R7. Okay, as we discussed. Now see, this is our this was our problem statement, right? So this 40 to 44 are the memory locations, and in that locations there was some data as here, and we want to add these bytes and store the result somewhere in A and R7, right? Now see, same program now we want to do in C language. Now this is a transition actually. Why we are doing this type of coding? Because I want to slowly move you move to the C language, embedded C. And we can note the differences, how that program we were writing in assembly, the same code, how we can convert into C and so on, right? So I have written the same type of problem solution, but in C language. So we'll go to the Keil here. So you can see this program I have already written here, and already it is in debug mode to save the time. So you can see I have declared one array here, right? So it's an unsigned char multi-array. Okay, the name is given as multi-array here, and already I have stored some bytes here, 2573. So these are decimal numbers because we are not writing like 0x and something like that. So by default it is a decimal. So these you can assume as a decimal array which is stored here as a multi-array, and we want to add all these and store somewhere in a variable unsigned int. Now why unsigned int here? Because the result of the addition will be greater than 8-bit, right? So I am taking a space of 16-bit for result, and I am declaring that sum is equal to 0 initially. And there is some count. That count will count whether we have covered all the elements or not. So this is what the initial variables I have declared. Then this is a for loop. Now this time I'm starting count from 0, and I'm comparing in each iteration whether count is less than equal to 5, and I'm incrementing count plus, right? So when we start the for loop, initially count will be 0, and it will check whether it is less than 5. If it is there, it will go in this, and it will add the contents of array, the first byte. See, when count will be 0, multi-array 0 will be added, means 25 will be added in the sum. Okay, then count will go on incrementing. So when count will become 1, it will again check whether count is less than 5 and again add. But this time it will add multi-array of 1, means 73. Accordingly, it will go to 4, means all these bytes will be added into sum. Then when count becomes 5, this condition will false, and it will come out of the for loop. And here I have this infinite while one loop as we write as jump in our assembly program. Similarly, here I am writing while one, right? So in this way, we can see the execution of this code, how this program. See, here we are not bothered whether it is accumulator or which memory location. That care, who will take care? That care will be taken care by what we can say a C assembler compiler. It will convert our program from C to assembly and finally to the machine. So you can see the big program is there here. We are not bothered now how much big is and how it is handled. We will be bothered that how this will executed and how I will get the result in sum. So I will just execute this program. So I will stop the debug session for a while. There was some issue, so I will again start the debug session. Okay, here, so now it is in the first line, and I will add watch here. Suppose sum, because I'm interested in sum, and the initial value is suppose 0 here. Now I will execute the whole program and I will see the result here. See here, it is D5 because whole program is executed now. You can check step by step as well by using this step by step, but now it is whole program is executed. Now why D5? See here, you are expecting result 213, right? Now you can open something as converter from decimal to hexa. So if it is 213 in decimal, the hex number is D5. So I can see the result D5 in the sum. In this way, you can use array for such a type of multi-byte addition. Thanks for watching.